Okay, so hello everyone. Thanks again for being here today. My name is Denis. I am a develop goodness developer advocate here. I'm a developer advocate at Couchbase. For those who don't know, Couchbase is a NoSQL database, fairly similar to MongoDB, I would say, but designed for more critical scenarios. So most of the clients using Couchbase usually have like 15, 50, 100 nodes in the same cluster. So this is really designed for more, Couchbase really shines in more critical scenarios, and that's why we got a lot of experience with Kubernetes, with operators, and I would like to share a little bit our experience today, and well, talk a little bit about this topic, which is um, we change language, we change frameworks, but whenever we talk about databases, we like to be very migrate, try to avoid any issues. So we like to stick with what we already know, and this is kind of a hot topic right now. I would like to start with a small tip for you. Whenever you are reading an article online, if the article starts with a question, the answer is no. So those are all real articles from 2016, where you see, okay, should I run my database on Docker? No. Is Docker good for your database? No. So those pretty much I went through a few hundreds of articles, and they were all in all those articles. The answer was in 2016 was no. You should not run your database on Docker. Back then, the main the main argument was databases were containers are supposed to be stateless, and databases are stateful applications. And yeah, that's still true today. But let's fast forward to early 2019. Now, pretty much all articles out there are not questions anymore. You have articles like running database Dockers at scale, or running your database in 5 minutes. And you see, like in just 3 years, the mindset completely changed. So the natural question is, okay, what have changed then, right? Why in just 3 years we completely changed our opinion about that? So first of all, in 2016 we had many challenges related to running database on Dockers, but we have to agree that running a database on a Docker container is far easier and faster than installing this manually on a bare metal. You can also separate compute from storage. So yeah, if you need a faster storage, or if you want to increase your storage, in many times you can do that without with the database still online. You don't need to shut down the whole thing and upgrade and then bring everything back online. We also have now production graded images. So all the cloud providers, they basically did a lot of testing and certify that, okay, yeah, now it's cool to, we certify that, yes, you can run this or that database on Kubernetes. I think SQL Server, for instance, had to do a lot of changes, and they were one of the latest, one of the last database to release a official Docker image. And of course, Kubernetes is just, Docker is just half of the story, right? Because you still need to have some sort of orchestrator to manage the containers for you, especially when you have stateful applications. And of course, one of the another issues we have is databases are highly configurable systems. So do I have to generate a new image for every possible new configuration? Or how do I enforce that, okay, all my Docker containers are running the same version, the same configuration? So this was also one of the challenges back then. Right now, we actually have something like CRDs in Kubernetes. So you can, from a single image, you can specify exactly what you need, how many memory, how many nodes, and then from there, all your cluster will be deployed with the same configuration. But that doesn't change the fact that databases are still stateful and containers are stateless. So I can't simply queue a pod, for instance, in Kubernetes, when I'm running a database, or start another pod. There's some things that I have to do in order to connect this new pod to the cluster. So in most databases, you have, for instance, once you start a pod, you have to connect the pod to the cluster. You have to trigger some data rebalancing. You have to do a lot of checks to make this node available. And that's why probably you guys have heard at this point already, we had this operator framework in Kubernetes. So an operator is pretty much like an application that listens to events in your Kubernetes cluster, and according to these events, it can take some sort of actions. And when you pack a set of listeners in a single application for a given purpose, we call this an operator. We were a little bit lucky because when we started with our operator, we didn't even have the framework operator wasn't a thing, and we actually tried daemon sets, we tried sidecars, containers. None of them worked, and then finally we came to the operator framework. Like, we started this more than 2.5 years ago, and that was the only thing that, okay, now we are confident enough that this will work. And why operator is such a big thing for databases? So mainly because you can pretty much have a database as a service solution within your cluster. So for database providers, you don't need to create your own DBaaS solution. You can just go ahead and say, okay, instead of using a DBaaS solution, just install this operator in your application, in your cluster, and then you have a DBaaS-like experience. Of course, there is this conflict with, okay, when should I go to a DBaaS? When should I go to Kubernetes? This will probably change in the near future because the scenario for operators is rapidly changing. But right now, I would say that the DBaaS, database as a service, is far more easier, at least for like the main out-of-the-box databases. It's also cheaper for small and medium applications, but it still lacks flexibility. So you can't fine-tune your database, and most of the performance you can get from those database as a service are pretty much average. Some of them you don't have an option to do caching, and well, you can't adjust or boost the database to what your application needs. So you can use just what they offer, right? Like in Dynamo or Cosmos, for instance, you can mostly increase the number of reads and writes you want. While database on Kubernetes, it's still a little bit complicated, I would say, especially regarding persistent storage. But you nearly have the same flexibility as the bare metal. It's pretty much one of the best options when you have a large number of nodes in the cluster. So for instance, in Couchbase example, eBay, PayPal, LinkedIn, they have more than 100 nodes within the same cluster. And for them, when you have this number of nodes, automation is kind of mandatory. And for them, this is really helpful. But of course, this will probably change. The tendency is that operators and persistent storage will get easier and easier in Kubernetes, and probably 1 or 2 years from now, it'll be much harder to decide, okay, when should I go to a DBAS, when should I go to a database on Kubernetes. Okay, let's do a small demo here. Let's deploy a cluster on Kubernetes, and let's play a little bit with the operator. So, okay, I already have here, I have 3 nodes running on AWS with Kubernetes, and here I already have the Couchbase cluster, Couchbase operator running. Oh, sorry, get pods. I have the Couchbase operator running, and I also have the admission controller. So now we also validate the YAML file you apply, because back then this wasn't possible. And in databases, it's kind of critical because you can really mess up with your database if you don't have a admission controller. You can maybe change a small YAML, pass a wrong parameter in your YAML file, and basically kill your database. That's why we also have an admission controller for that. And to create a database on Couchbase, for instance, on Kubernetes, we can run kubectl, create -f Couchbase cluster, and this will create the cluster. If we come back here, so this is how my CRD looks like. Basically, I specify the version. I can specify all the memory I want for each service. I can specify the bucket. Bucket is similar to a schema in a database, and of course, how many nodes I have. And here we have thousands of configurations here. If I run kubectl get pods, probably we should have one here already. Yeah. Let's access our first node here. Okay. So this should be okay. Okay, so first thing here is I will also deploy an application to consume, and let's play a little bit with the application running and the database, and try to recover and simulate some failures. First of all, let's go to security. Let's add a user and call Couchbase simple. Couchbase simple. Don't do this at home. Okay. Let's see the state of our cluster now. Okay, we almost have all the clusters running. So here, if you go into server, you see, okay, I already have all the 3 nodes, and basically the operator takes care of, okay, there is a new node here, let me join this node to the cluster, let me trigger data rebalancing to move some data to this new node, and well, now we already have everything online. So if I come here and create, let's create a new bucket. Bucket again is something similar to a schema. So I can come here and say, okay, GrillOps, add a bucket. Oops, yeah. So now we have our bucket, and it disappeared, right? Why it disappeared? Because the YAML file is a single source of truth. So whatever you change in the database, it will be reverted by the operator, because you have to rely on the YAML file, and if someone goes to the interface and change anything, it will get reverted by the operator. Okay, let's deploy our application then. So I have here a very simple Java application. So yeah, I have here a very simple Java application. It's just a Spring Boot Java application that inserts some data on the database every minute. So here, let's go back, clear a little bit. Let's now kube control, create -f Spring data app secret. And now I can also deploy my application. Cool. Now if you come to dashboard, actually buckets, statistics, we should see soon. Just what? Oops! I did something wrong here, probably. So sorry, my user has the wrong username. So delete -f. Come back here to security. Let's delete this user. Add a new one. Couchbase simple. Okay, and now we can come back to our application. And yeah, it's running. If you come to statistics, now we see that, okay, we have, our application is now inserting data on our database. Okay, let's do something crazy here. Let's kill one of our nodes. Kube control, delete pod, cb example 0002. Okay, if we come back here, you will see that, yeah, we just lost a node. What I have to do to recover from this? Basically nothing, because first, Kubernetes will obviously bring this node back, but the operator will realize, okay, there is a new bucket here. This is the state of our application. I have specified that I want, well, in this case, I was supposed to have 3 nodes here, 3 replicas. But with 3 replicas, I still have copies of the data, right? So when I lose a node, I can just bring this node back. The operator will join the node to the cluster, will trigger data rebalancing to, okay, now I only have like 2 replicas of the data, and I need to copy some data to this new node, and then you are back online. So for a lot of the basic stuff that DBAs do, like in case of failures, you can automate with operators. So if you see probably here, yeah, now we already have the new node, and we are already rebalancing data. So moving some data from those 2 nodes here to the new one. And that can automate a lot of stuff. So this operator is basically the core strategy of our database as a service solution. So we will launch a database as a service solution in the future, and all the operator here, you can deploy yourself the operator, but we will use the same operator to support our database as a service solution. Okay, what if I want to scale up the database? All I have to do is to come here and say, okay, instead of 3 nodes, I want to have, let's say, 4. Then I can come back and say kube control, delete, replace minus F, Couchbase cluster. Let's come back, this was 1. Let's keep this with 1. Couchbase cluster. And okay, so the operator knows that, okay, I already have a rebouncing here in progress, so it will wait for the rebouncing to finish to upgrade the database. What are the other things I can do? So we support, for instance, what if I am upgrading the version of my Kubernetes? Yeah, you can do this and without killing the database. What if I want to upgrade the version? So I can just come here and say, instead of Couchbase 6, I can run Couchbase 5, 6.5, and it will automatically upgrade the database for you. The operator will automatically upgrade this for you. What if an application reads more than write? So what I can do is something like, okay, I have data here. I might have just four nodes for data, and here index and query, and I can say I want 10 nodes just for read and write. So I can upgrade the database according to what I want to boost. And same, right? If my application writes more data than read, I can just do the opposite. And one cool thing here is you can actually adjust the hardware according to the service you are running. So, for instance, data naturally needs more IOPS. Indexing needs more memory, and query needs more CPU. So you can run different images or different machines for different service. So you can adjust the hardware according to the service you are running. And of course, there are many other things here. So for instance, we compile logs, we do a lot of other stuff. Automated backups is something coming to the future in the future, but we are not paying a lot of attention on this right now, because you can just run jobs on Kubernetes, running to run the backup and storing some S3 files. So this is something that most of the DevOps people can do manually, quite easy. Right now, we already have a lot of people running this in production, and this is becoming pretty much the standard solution for staging environments, at least, because you can easily, okay, every new build, you can spin up the database, you can load data automatically and destroy and load the whole cluster. Yeah, here is our we scale out here. So yes, now we already have like a fourth node, and the operator again is already triggering data rebalancing. Are you seeing my screen yet? No. Okay. Yeah, something happened here. Okay. Okay, I'm back. Okay, yeah, so let's go back here a little bit. Whenever we talk about databases on Kubernetes, one of the main concerns is, of course, storage. So back then, initially in Kubernetes, we have only ephemeral storage, which means whenever you lose a pod, you lose all the data in it. We saw some clients running the database on ephemeral storage because they have a lot of replicas. But of course, if your whole cluster goes down, your whole Kubernetes cluster goes down, yeah, sorry. But this was okay for them because they had backups and they have quite large clusters. So it's still a little bit risky, I would say. Then, of course, the natural second option was remote persistent storage. But this is not an appropriate solution for databases because the latency quite can make your performance. It can really affect your performance. So for some use cases, we saw some clients doing this, but because they have a really good network and a really good storage. Remote persistent storage is more like, okay, it's a general purpose solution and you can use for storing data, but I would say it's not the best option for database. And since April, now we also have local persistent storage for Kubernetes, in Kubernetes. So we already have in the past, but now it's GA. And one thing to keep in mind in local persistent storage is that this is not a general purpose solution. There is a lot of trade-offs on using local persistent storage. One of them is, of course, inflexible placements, because when you have a local persistent storage, we are tightening your pod to the node. And if your pod dies, the scheduler in Kubernetes will schedule this pod to be started in the same node again. And this is kind of problematic in some sense, because Kubernetes is kind of diffuse a little bit the purpose for Kubernetes, because you are supposed to not know where the pod is running, and now you're fixing the place where the pod is running. But for this use case, is a fair trade-off. Local persistent storage is also not usually replicated, so your availability is tied to how long the disk lives. And it also requires some data preparation, some disk preparation, so it's not something that's as easy as remote persistent storage, for instance. But yeah, but it's okay for databases, because, well, databases in general have been dealing with node failures for more than 50 years. So yes, we do know how to manage if node with split, if we have a split brain. We know how to deal with node failures, with disk failures. So it's okay for a database. What we really need is a fast way to access the database. Yeah, back then we used to run, before local persistent storage, we used to also run host path, use host path, but host path has a lot of problems, especially with security, because you can point any directory in the disk, and local persistent storage already used the persistent volume interface. So yeah, from now on you can basically go ahead and use the local persistent storage for everything, especially because if you need some disk accountability, or know, okay, which pods are using which disks, or security and stateful sets, because we with local with host paths, you have to implement, you can't leverage stateful sets. And another common question is, what about performance, right? What's the performance what's the difference between running my database on a container versus running my database on a bare metal? Our tests show that, okay, yeah, I don't know if you guys are familiar with Yahoo Cloud Serving Benchmark. It's a series of benchmarks to test the performance of a database. So our tests show that, okay, for some workloads, there's no difference at all. For other workloads, you might have a penalty of up to 10%. So yeah, it is slower, so it doesn't make sense for me to run database on Kubernetes, for instance, without leveraging operators or some other stuff, because yeah, you have some penalty here, so you have to at least get some benefit of it, and one of those benefits is, of course, automation. Just an example here, this is some of the stats of workload A. So you see that yeah, in one use case we have 1% penalty. In a second use case we had the same performance. So in here on workload E, yes, we have something between -3 and -9 performance downgrade. So this is one thing to keep an eye, because yes, there is some penalties on this. Of course, this depends a lot on the kind of workload you are running. In our case, for instance, for workload A, just to go back here, workload A in Yahoo Service benchmarking, it's a mix of 50 reads and 50 writes. And because of how Couchbase works internally, that we already have a managed cache at the top of the database, whenever you write, your reads automatically get cached. So for us, there is no real difference here. But for workload E, when you run a series of small queries, yes, this will make some difference, because now you're running on a higher abstraction. Okay. Yeah, and in general, of course, worst case is try to increase a little bit CPU or increase a little bit memory if you're running a database on containers, or depending on the number of the nodes you are running, add an extra node. But yeah, try to use some operator to automate and get more benefits of it. Of course, when I first gave this talk, Couchbase was actually the first company to release an official operator. But since this year, we have pretty much every single database right now has an operator. Not all of them are as easy as this one. Just yesterday, I watched a talk about the 3 main operators for MySQL. And well, seems like my impression was scaling up, recovering from failure in MySQL is way more complex than here. But I personally see that this should be the database on Kubernetes. Yes, it's still a little bit complicated right now, but it will be probably the default solution in the near future. And we will have something more. We will stop managing everything on bare metal and by default deploy everything on Kubernetes and have a really good automation. There is a series of talks from CNCF on running other databases on Kubernetes. So yeah, you might check it out, because then you can see how other database works. And yeah, this is pretty much what I have, because demo went straight. So if you have any questions, feel free to ask. Questions?
So this example is regarding Couch database. Did you experience with any other types of databases under Kubernetes?
Well, my main experience is with Couchbase, because this is the company I work for. I tried with Postgres, because there is some famous operators out there. One made by Zalando. I think it's most popular.
Patroni? Maybe Patroni or something?
The one that I know is made from Zalando. I know what's the name of the operator, but this is the most popular one. And my friends there told me that yes, they are running on production already. I personally don't have experience managing this operator, but I know that this is one of the most popular ones. MySQL has the official the Percona and 2 others, but I don't have a lot of experience managing them. I know that this is popping up everywhere basically, okay. And yeah.
And in Couchbase, when we're talking about like a Couchbase cluster, basically each node of the, let's say, of the database cluster has a copy of the data, right?
Yes.
So basically, there's nothing shared. Data is not shared. Like, for example, not unlike like an Oracle database cluster.
Well, the way it works is first, Couchbase is masterless, so each node is actually slave and master of a few shards and slave of others. And each node has, you can specify how many replicas you want. So for instance, a node, I'll request for all documents in a single, our request for a document which are in a shard will always go to the same node. And this way we guarantee that, okay, you have strong consistency. But if this node fails, we have replicas somewhere. So then we will promote this other node. So in this way, we avoid like having a master node, and if the master node goes down, your whole database becomes unresponsive. So in our case, what happens is if a node fails, only the data that was in this node will be a little bit will be for a short period of time unresponsive. So in some sense, for us with this architecture, it's a little bit easier to implement an operator because we can recover faster from the failure. But was this your question?
So basically, my question is regarding the storage, like the database storage level, because I think when it comes to the having a persistent storage under Kubernetes, there will be a lot of challenges. Unfortunately, I don't know much about Couchbase, but for example, for Postgre, basically it's also shared nothing. So basically, you have like a one copy and a replicated copy. For Oracle, for example, they have like a shared storage.
Yeah.
It's like in the Oracle cluster, it's a bit more, I would say, sophisticated. But then when I try to think about having storage under Kubernetes, this will be really challenging. This is why I was really curious about Couchbase. How is the storage is done?
Yeah, we share nothing between storage. So each node is a completely different application. So a complete. They don't share the storage itself. Each node has its own storage. So that's basically how it works. I think it's similar to Postgres in some sense.
Okay, great, thanks.
Any further questions? Okay.
Generally, operator idea is okay, but I have question. What happens when operator is going down?
So that's a good question. So
because I saw, please correct me, I saw only one pod of operator, and I assume it's stateful.
No, actually the operators store its state on etcd. So the operator is can if the operator dies, it's okay. It will get restarted by Kubernetes, and then it will load the state of the cluster from etcd. So yeah, this is a really good point, by the way. Yes. So this is not a big issue. That's why we only have one instance of the operator, and also this guarantee that okay, you are not adding too much the complexity of the system, because if you have to manage another stateful application, yeah, then probably it would be, I don't know, it won't worth that much using an operator.
Any further questions? Okay.
I don't know much about operators, but I was wondering how do you monitor one? Is it running on Kubernetes masters, or like it's deployed as just an application on Kubernetes cluster?
Yeah, so the operator is deployed like an application, but you do have to install the CRD. You have to install some definitions for the Kubernetes learn that there is a resource type, in this case Couchbase, right? Or a resource type Postgres or resource type MySQL. So you usually have to install the CRD and some other stuff. And the operator itself is just one type of application that extends the Kubernetes API and framework. And yeah, and then in some sense it's just an extra application, but this application itself listens to all events in the cluster.
Yeah, okay. But how do you monitor such an application? Do you have like Prometheus endpoint or?
Yes. You can in Couchbase itself. We do have in our case we do have a lot of statistics from the REST API, and those all can be pushed to Grafana, to Prometheus and Grafana, and you can write all the alerts there. And of course, right, if you you don't need to do this manually, right? You can automate with the pod.scaler, and you can say, okay, whenever if my disk is running out, please scale my disk. If I have the CPU of the database, it has been for more than 1 hour in 100%, add an extra node. So you can kind of automate this. But this is something more like, okay, this is the DevOps engineer actually know how the application works. So this is up to them to implement this type of logic to say, okay, when should I upgrade or downgrade my database? But yeah, you can basically monitor everything on Grafana.
And one more maybe. So this operator, it just spawns databases for users in their namespace, or how does it work?
It's one operator per namespace.
Okay.